Hello, I'm Dr. Harper. This video is in Management of Operations ABC Inventory Classification Problem number 1. I call it problem number 1 because there are other problems. This is just one problem with an ABC Inventory Classification. So let's bring up the problem. Company B is conducting a review of their inventory policies to determine any needed changes. The annual usage and annual average inventory were obtained for each SKU item. A constant carrying cost and ordering cost were used for each SKU item to compare current strategies with optimal strategies. And so the unit carrying cost is 64 cents per dollar per year. Ordering cost is $80 per order. So here are the SKUs, and here's the annual usage, and then the annual average inventory. Question 1. If the observed annual average inventory level of a SKU item deviates either greater than or less than a fixed percentage from the optimum annual average inventory level, then action is indicated. How many SKU items are identified for action due to different criteria? And here are the answers here. In other words, if the actual observed annual average inventory deviates more than 20% from the optimal, well, 4 SKU items did. More than 50%, 2 SKU items did. More than 80%, 1 SKU item did. Okay, so 1 SKU item is really in trouble. More than 20%, 4. And so how do we do this? Well, then once we do it, question 2 says, what is the possible annual total inventory cost savings, which is the ordering cost and the carrying cost together, from current inventory policies to an optimal inventory policy for each SKU item, running to the nearest dollar. And so when you compare the current with the optimal, the current total inventory cost, which is the ordering and carrying cost together, is $10,892. The optimal is $9,819. So we can reduce it by $1,073. So that's just for this problem. Okay, well then how do we get all these numbers? So let's bring up Excel. So now in Excel, I already have the answers here, but I'm going to go through and show you how to get each one of them. First, let's enlarge this a little bit. So here is the carrying cost and ordering cost. So the ordering cost, we'll type this in 80, return, and 64 cents, 0.64. This is annual. The EPP is equal to the ordering cost divided by the carrying cost. And there that is. Okay, now it's for the SKU usage in the observed inventory, call it inventory number 1. Let's bring this over. And fine, let's just go ahead and take these right here. Actually, let me bring this back. Let me show you what I'm going to be doing here. Let's bring this in here. I'm going to work this problem. So right here, let's just blank all this out here. And actually these down here. And let me just go through them. Okay, let me show you how to build it. Okay, first of all, let's minimize this. Let's take the SKUs, annual usage, annual inventory, Control C, copy. And let's bring back our Excel, and let's just put these in right here. Control V, paste, and there they are. Okay, and let's bring this back down to 10. That's all we really need. Okay, and there it is. Okay, now EPP we know is 125. We could just copy that all the way down. We're going to be using that. Okay, and now first of all, here's our observed inventory. Call it inventory 1. The question is, what's our optimal inventory level when we have our EPP? Well, we can determine that. Well, I have the equation here. That's inventory 2. I have the expression here to calculate this. But where did this expression come from? The square root of M, usage, over EPP over 2. Well, down here I derive it where the frequency given in my lecture, the optimal frequency is the square root of m over 2 times n times EPP. Well, the demand is equivalent to m. In other words, m is usage. Okay, but that's the same as demand in dollars. Q over 2 is the average inventory. N equals 1. Because the number in the class, we're considering each SKU its own class. So the number of units, number of SKUs in a class is 1. So we're doing them one at a time. And then finally we have the Q equals D over F. So Q over 2, which is our average inventory, this is our average inventory, is D over 2 divided by F. Okay, so now I substitute in M for D right here, D over M over 2. And F is square root of M over 2 times N EPP. I put that right here. And so there's my M over 2 over the square root, and that's going to be my F. Well, to do some algebra here, I put everything under the radical, where I have M squared over 2 squared times, and I flip the, this is divided by square root. I put the m in the denominator, 2n EPP in the numerator, okay, and then I just collect terms. When I collect the terms, the n is 1, the m's cancel out, the 2's cancel out to 1. So I have the square root of m over EPP over 2. And that's what I put up here. So let's do it. Equals the square root of the m, which is right here, m, times EPP, which is 125, divided by 2. And there it is. And then I can copy that down, and that's my optimal inventory level from EOQ, basically EOQ theory, applied to annual dollars, usage, and ABC inventory classification. So let's take an index here. So we're talking about a percentage deviation. So let's take an index. I'm just going to say inventory 1 right here, divided by inventory 2, and there it is. And let's just divide this. So there's the ratio between the two. So what we want to know is the percent deviation either greater than or less than this by a certain percentage, a fixed percentage. Let's bring this up like this. There we go, a fixed percentage. Well, the way we're going to do this really simply is just saying, okay, let me just take a percent deviation. So this would be in percentages. So this is going to equal the absolute value of 1 minus this. In other words, if it's equal to it, it's going to be 1. If it's more than 50%, it's going to be more than 1.5. If it's less than 50%, it's going to be less than 0.5. If it's more than 10%, it's more than 1.1. If it's less, it's less than 0.9. What I'm saying here is, so I'm just taking 1 minus that. Okay? And the absolute value of that times 100 to put it in terms of percentages. So this is 36. Now I can copy this down, and notice when I take 1 minus that, this is 8% below 1, 5% above 1, 16% above, 47% below 1. So this is the percent deviation. And so that now I'm saying 10% here. Say, well, okay, let's say, I'm just going to say, well, if it's more than 10%, then I'm just going to say yes. Okay, then over here, I'm going to say equal. If that is greater than my 10, F4 to fix that, then I'm simply going to say yes. Is it greater than 10%? Yes. Otherwise, I'm just going to say, leave it a blank. Don't care. Well, that is. The next one is not. If I copy this down, it's going to be blank. So I copy it all the way down. So how many is greater than 10%? 1, 2, 3, 4, 5, 6, 7 of them. Wow. Okay, but now I have this. I can say, what about 20%? Oh, it goes down to 5. What about 30%? What about 40%? What about 50%? What about 60%? Whoops, 60%. Whoops, 60%. And see, I put a 0 in there. Put that back up. Go back to where you're supposed to be. There we go. 70%, 80%, 90%, 100%. Well, this is 106% above. Okay, 0%. They all are. None of them are exactly. Okay, well, I had 10. You can put in there whatever you want. And notice what I did. Down here I say, well, 20% there's 4, 50% there's 2, 80% there's 1. That's pretty much what I'm doing here. So 20%, there's 1, 2, 3, 4, 5. Did I say that? 20% there's 4. Oops, see, that's wrong. 20%, 1, 2, 10%. There's 1, 2, 3, 4, 5, 6, 7. 20%, there's 1, 2, 3, 4, 5. So 20%, there's 5. See, this is wrong. Need to change that. What 50% should only be 2. Let's see what we got here. 50% is only 2. 60 is 1. 70, 80% is only 1. Yep. So it's 5, 2, and 1. There we go. So I don't know where 4 came in. Well, let's see. 10, 20, 30. 30% is 4. Okay. But anyway, you get the idea. Okay, well, that's the first question. Now, the second question says, this will tell you what to do. These are action items. And it tells you which SKUs to go after, which SKUs to look at, which SKUs to modify. It's very practical. Second, though, is the motivation for doing it. What is a possible annual total inventory cost savings from the current inventory policy to an optimal inventory policy? Looking at each SKU item running to the nearest dollar. Okay, well, let's do that. Okay. Well, over here, this is going to be our observed inventory. Carrying cost is 0.64. So let's sum our inventory. Sum this. Okay, make sure I got it right. All of them. Yes, I did. And let's sum our optimal inventory. Right here and go all the way up to the top. Let's make sure I got all of that. Oops. Make sure I got all of that. Yep, I summed it all. That looks good. I'll put the 6.4 down here. 0.64. Okay, and then I'll get the total cost equals the sum times the unit cost. This equals the sum times the unit cost. Okay, so there's the unit costs. Oh, okay. And then over here is our frequency. Well, we don't have frequency. All we have is the average inventory. So how do we get our frequency from our average inventory? Well, I have the expression here. Now, where that expression came from is simply this. The frequency is, again, is D over Q from the fundamental relationships. Well, D is the same as M. Q over 2 is average inventory. So therefore, Q is going to be 2 times the average inventory, right? And so the frequency equals D, which is M, over 2 times the average inventory. And that's where that came from. So the frequency is M over 2 times my inventory. So let's zero this out. I'll zero all of this out. So all this says is that's going to equal, let's come back here, equals my M divided by, open parenthesis, 2 times, and this is my observed average inventory, which is that, in parenthesis, return. Okay, and then my optimal inventory equals my usage again, which is that, divided by 2 times my optimal inventory, which is that. And there they are. And then I copy these down. So that's the frequency. the estimated frequency. So let me sum each of these. That's the total number of orders through the year. And notice the observed is 78 and the optimal is only 59. Whoops, let's bring this over here. There we go. The observed is only 78 and the optimal is 59. So it significantly reduces the number of orders. So within the ordering department, purchasing department, it really does make things more efficient. Okay, over here, the actual inventory is pretty less. It's less. Okay. I mean the cost. Actually, the cost is more for optimal. So we're increasing our inventory. Interesting. We're increasing our costs here. Yeah, but we're significantly going to be decreasing our ordering cost. So the savings here is in our ordering department. This is going to equal our ordering cost of 80. There we go. And this is going to equal 80. There we go. Okay. And now this is going to equal this times this, equal this times this. And there's our costs. Okay, let me make sure I do this right. Yep. Good. Looks pretty good. Okay, then I copy this all the way down to here, and then just make sure I sum everything. Did I sum everything? Oh, I didn't sum everything. Okay, let's see here. Let's back this up. I didn't get this last number in. Okay. Make sure you sum all of it. Okay, and then copy this over. Okay. Always double check. Did I sum it all? Yes, I did. It's so easy not to. Did I sum it all? Yes, I did. Good. And there's going to be the values. Okay. Now then I can just bring these up over here. And I just brought these up, the observed. I can just take these out here. Just bring this down like this. There we go. Now the observed, there's an inventory cost of the observed right here is going to equal this. The optimal is equal to this. Ordering cost observed is equal to this. This is equal to this. Okay, and then the difference is going to be, in this case, this minus this. In this case, it's this minus this. Okay, fine. But what's really of interest, what's really what we want to do, is going to be the totals. So this equals the observed, this plus this, and this is going to equal this plus this. Okay, this doesn't look like ordering cost. Yep, that's right. Yep, because it, okay, notice these are the same because it's at EOQ. At EOQ, these will always be the same. So now, the difference is this minus this, and there's going to be our difference. See? And so notice since my optimal here, the optimal will always have the inventory and ordering cost the same. Okay, so we have a total cost of just 2 times this, and that's going to be minimizing it. But we see here that our inventory cost is much lower than our ordering cost. So where do we save our money? We save our money on the ordering cost. Okay, because the purchasing department can be run a lot more efficiently by doing the optimal policy. Now, we may not go all the way there. This is very practical. It just says, okay, well, how severe do you want? Do you want them to be so close, like a 5% here? There's only 1, 2 SKUs you're not going to look at. You're going to look at all of them. You don't have enough labor to do that much. Okay, what about 10%? What about 20%? What about 30%? Well, here's 4. What about 40%? Here's 3. Yeah, let's look at 50%. Let's look at those 2 first. Okay, and just look at just 2 of them. So how many resources do you have to start to making your inventory more accurate and more and lower cost? And so take the low-hanging fruit first. You do the first things first, and then you move on and move on and move on. So this is a very practical problem for ABC inventory classification. So I hope this helps. That's all I have for this problem. I hope this helps. There are other problems, but this is a really good place to start. It's very practical. Between now and the next time I see you, I hope this helps, and take care.